Energy efficiency is the key to the survival of our MSME. Let us see what all the steps can be taken to implement the energy conservation measures and the energy efficiency replacements inside the premises in our MSME segment so as to improve our operating profit margins. In our existing premises, if you see, our company is always running on the market demand demands, either it is weekly or monthly. So, the power bill is high sometimes due to lean production periods also. So, let us check our EB bill not to have a low power factor penalty. Sometimes we are not aware of this, but it is happening. Let us also see to it that the 3CT based APFC is there working at the EB incoming side so as to maintain a just slightly lagging around 0.97 as the power factor. Let us try to retrofit the load and capacitors on all the non-VFD motors 3 HP and above so that our power factor is always around 0.97 at the EB incoming side. Coming to the compressors as utility, it serves to the pneumatic demands, but lot of leakages are happening during the ideal condition or the off condition. At that time, let us see to it if it is a batch process, whenever the machine or the industry is off during the batch time, off time, definitely check for the leakages and correct it, because the leakages silently increase the electricity bills without our knowledge itself. All our blowers, let us try to monitor the pascals deliverable in the suction or the delivery of the blower in such a way that if the suction pascal or delivery pascal is more, definitely this is going to increase our blower power bill, and ultimately the monthly power bill also increases as such. So, the methods to implement or retrofit in our MSME, let us see. The generally practiced energy efficiency methods I am just trying to discuss here. VFD needs to be installed in all our production machines for the flexibility of operations. This is not meant for power savings, but it is meant for the flexibility of operations. Whereas the VFD retrofit installed on the blowers or pumps or compressors, especially centrifugal type, they are all basically variable torque loads, and definitely it gives an excellent or appreciable energy savings. Also, wherever you find the belt operated machines, either in your production or in your utilities, let us try to replace these rubberized V-belts to polymerized cogged belts and pulleys, and definitely this gives a straightaway savings of 10% on the existing energy consumption on the machine, either in production or utility. Also, you can plan for solar heating or solar preheating. Let us try to make use of the ambient temperature wet bulb and dry bulb, as well as let us go for solar rooftop also. But we have to keep in mind 1 megawatt of solar rooftop, it costs around 5 crores to generate around 5000 units of electricity per day, whereas the same 5000 units of electricity per day can be recovered by spending less than a crore in this energy conservation and efficiency. This is what we are more interested about it as such. So, the day-to-day operations can be fine-tuned. Let us say relative monitoring, energy monitor of your production machines or the auxiliaries or the utility prompting to be, these relative energy monitoring will prompt which machine is going higher consumption, which machine is going less consumption. Accordingly, we can take the steps to correct that one. The production machines or the auxiliaries or the utilities, they need to have an individual kWh meter and a run hour meter. I will just discuss in length later, but it is possible to have, if it is possible, let us try to have it an individual kWh meter. It doesn't cost much, around 1500, 2000 only, but it can be installed in all your production machines in your auxiliary and utilities. This kWh and run hour meter for the utility, definitely you can see to it that it is matching to the production. Also, the maintenance type or the MSME is following the straightaway time based monitoring and practices. Let us go for condition based monitoring with the latest gadgets available. Either it can be outsourced or it can be kept in the premises with portable or in situ or digital or IoT devices. That is coming up in a big way. We can plan for that also as such. The energy losses happen in our utility right from day one of the installation. Let us try to discuss with the utility OEMs and see to it what all the condition based monitoring practices can be done and improve the installation and improve the performance of the existing utility and reduce the energy losses in the utility. First of all, let us try to do the monitoring the electrical distribution either shift wise or day wise or weekly wise and month wise, both the kVA and kilowatt readings apart from the basic parameters like volt and amps. This kilowatt and kVA will say whether we are consuming daily either more or less, we can definitely see it will have a relative impact on our production and the power consumption daily it can be compared upon. Next comes the end-to-end energy losses that is happening in the utilities and auxiliaries. This is what we see in the compressors, fans and blowers and pumps and even in the HVAC systems. The generation, distribution and usage. What are all the losses happening from the generation to usage point, either in the compressed air pressure, or if it is a blower means it is a static Pascal, what is the drop from the blower end to the delivery end. And if it is for the pumps, what is the pressure that is for the given flow of the pump, what is the pressure maintained at the generation at the near the pump end, and what is delivered at the process side. HVAC side also we have to look into the air circuit and water circuit separately, and definitely a lot of scope is there in the HVAC segment to have an excellent energy savings possible. There is a wide band of energy band or the efficiency band that is in the utilities is happening. This is similar to the B 5-star or 2-star rated, but 5-star versus 2-star rated equipments. If you see the efficiency band is around 30 to 80%, the existing machines, existing equipments in the utilities or in the production side are all decade old machines. These are rated at, are running at 30 to 40% efficiency only, but the latest IE5 or the say the 5-star rated machines or the equipments, they are operating at 80%. If you see on the motor side, the government has already taken an instructions, has given us the instructions, go for IE2 motors from 2018 onwards. Have we started replacing our old motors from up to less than 10 HP I am talking about, the energy saving scope is more than 10% is available here. Then comes the IE3 motor or IE4 motor or IE5 motor depending on your person availability. The BLDC motors, the replacement becomes indispensable especially for the motors less than 10 HP. The pump efficiency varies from the existing pump to the latest generation pump, energy efficient pump, it's around 30 to 80%. Let us study the pump subsystem also. What is the pressure available, what is the flow available, what is the head available and what is to be delivered. Also this is applicable to the fan and blower system where we study the fan performance curve, and you see here that the efficiency is around 30 to 40%, how this can be increased upon to 70%, 60 to 70%. All our compressors what all we are running, it is running at around 250 to 300 watts per CFM, whereas the latest generation compressors, the energy efficient screw compressors, they deliver around 150 to 180 watts per CFM only. You can save around 25 to 30% savings in the compressor itself. So the VFD definitely it becomes a mandatory or a mandatory retrofit to the variable torque loads like the pumps or the compressors or the blowers as such. This is what I am just talking about, the combo meters of kWh and run hour meter to be installed on each and every pump or utility or any compressor or blower or for the production machines also. You know what is the kWh units consumed per day and multiplied by the run hours will definitely give the units per hour loading average consumed per day. You know the motor average loading. This will give an indication whether we are loading our motors correctly, we are loading our motors. Coming to the motors, the motor loading is always efficient if it is loaded around 60 to 80%. You have to monitor the basic power parameters like volt and amps and the kilowatt and kVA just to know whether the motor is running at the rated capacity, less capacity or more capacity. Why the motors are getting heated up? It can be it can be a warm motor, it cannot be a hot motor or a hotter motor or a cold motor. So idling motor is always cold, whereas a hotter motor is oversized, it is running overloaded. There the loss is more as such. So let us try to monitor the shaft RPM motor for the given for the given 50 hertz given by the EB supply. What is the motor deliverable RPM, either it is 1450 or 1470 or 1480 matching to the load at the for the given load, what is the motor RPM and the load RPM. This will give an idea whether what is the slip that is happening in our motors. The thermal image can either you can use a thermal gun or a thermal imager, basic thermal imager. I will just discuss in length later as such. So on the driven and non-driven and the top and bottom of the motors will definitely give an indication whether the motors are really hot or it is just warm only, and you can still, it is running healthy for your industry. Then comes the lubrication for the given motor. Conventional old greases are all just caked out. So let us go for a specialty greases where it is polyurea thickened lithium complex grease, which even the motor OEM suggests for 3-year greasing interval for these type of greases. So you need to go for a specialty greases for all your motors apart from your production machines. Coming to the ventilation of the given motor, the all around ventilation should be there for the motor so that the motor skins get the good excellent, being a TEFC motor, totally enclosed fan cooled motor, the ventilation should be there on the motor fins all around. Definitely this will maintain the motor healthy as such. The energy monitoring gadgets to be there in our premises, or it can be outsourced, or it can be, you see, these are all the areas which we can concentrate. Bureau of Energy Efficiency always say, let us try to monitor the energy consumption, then only we can target the energy reduction in the KWH I am just talking about now. I have taken about the electricity. Let us discuss later about the thermal and other aspects in the next coming bulletins. Any pump or any machine or any motor definitely needs run hour of 500 rupees and a combo of KWH meter of 1500, around 2000 rupees. This can be fitted on each and every production motor, utility motor, auxiliary motor and the utility machines. Definitely this should show the loading is a critical component to determine the efficiency of any given system, whether it is a production machine or it is a utility machine. Then the basic volt and amps and clamp on ammeter, it just costs only 1300, but definitely this will give an indication whether we are going in the right track as such. The single CT clamp on power meter, it's around 15,000 plus. Definitely it will give you kilowatt kVA, even it can even give harmonics also. What is the given harmonics in the given VFD loads? The non-contact type speed meter, speedometers, we are using this optical type. This is costing around 3000 rupees. It is you can just put a sticker on your machines. If it is a batch process industry, in the off time you can put a sticker, and either weekly or daily, depending on the criticality of the machine running and the machine performance, you can monitor the speed RPM of the motor of the machine and the delivered area where it needs to be monitored. RPM decides the productivity of your company, revolutions per minute. So you have to monitor the revolutions per minute in all your production machines. The productivity that is maintained by the correct RPM, that will definitely improve your productivity. The productivity or the RPM loss in the utilities, that will give lot of energy, that is loss to the energy loss to the industry, that needs to be improved upon. If it is a continuous operating industry, you can go for LED sensing digital stroboscope, and this will, it's a cost around 15,000, but it is definitely worth the price because you can see the without switching off any of your motors or machines, you can definitely see the slippage in motors or in the machines or in any of your process machines also. Then comes the digital differential pressure Pascal meter. It just costs around 10,000. It's a Pascal meter, digital Pascal meter, to know about the blower efficiency. For the given flow, if the static pressure is going higher and higher, you see, you are supposed to keep around 600 pascals for your blower, means if you are keeping around 1000 pascals, definitely the power loss is around 30% there. So let us see what Pascal we have to maintain to optimize the process. See what is the blower delivered Pascal, what is the Pascal demanded by the process. Both needs to be checked as such. Then comes this is the next stage of this one, predictive monitoring, electronic digital vibration probe and digital meter. Wherever the motors have a lot of vibrations, it just costs only 20,000, but definitely you can see the vibrations, whether it is the amplitude and the acceleration due to gravity, that is acceleration and the vibration amplitude, whether we are within the norms or whether it is above. So if that is above, you have to check with your OEM and what are all the corrections to be taken in your machine, it can be taken as such. The digital anemometer, to measure the air or gas flow, it just shows what is the flow that is deliverable by your blowers and what is to be checked there. Not only for the digital anemometer for the blowers, but all your compressors, let us say if it is 50 HP and above, it needs a thermal mass balance principle based flow meter, in situ flow meter. It's a single insertion type, and definitely you can know what is the compressor is delivering either it is 150 for it 1 CFM is delivered at 150 watts, or 1 CFM is delivered at 200 watts, or 1 CFM is delivered at 250 watts. This also everything can be checked if you have both the input kWh meter and the output flow meter, especially on the compressed air. Then comes the basic infrared thermal imager. This is becoming mandatory for many of the MSME segment now. This infrared thermal imager, it just costs 50,000 on a basic price, but it goes to almost 10 lakhs also, depending on your requirement and your criticality of your application. This thermal imaging of all your motors, machines and your the EB power boards and all your motor panels, and what are all the process temperature gradient, everything can be used to, everything can be monitored, can be detected, what are all the hotspots that is there in the process, in between process. Definitely this will show there is a loss. The hotspot is a symptom of energy loss, and this needs to be corrected. So the basic industrial thermal gun, it costs only 3,000 rupees, or engineer's death, this also costs just few thousands only. So these are all the instruments that is to be there in our premises. Always Bureau of Energy Efficiency says monitor your kWh to target your consumption, but it is not only the kWh, input kWh, what is the deliverable quantity in terms of Pascal, in terms of compressed air pressure, or in terms of pump pressure, in terms of whatever it may be the deliverables, that also needs to be monitored. So you know where we are operating the process, are we operating the process at the optimum level, and are we getting the right inputs, energy inputs given to the process, and where we can optimize that. All these energy conservation measures and energy efficiency replacements, this I have discussed in my book Energy Books, which has plenty of case studies inside, and let us see to it that you can make use of the books, read the books, lots of case studies are there, and make use of it, and whatever the energy savings done in your premises, definitely you can share it to others. It is for the betterment for the industry, for the MSME segment, and it is betterment for the nation as it. Thank you.